Okay. Uh, Hello and welcome to the new IO benchmarking framework being integrated into LKFT. Yeah, next slide. And by the way, my name is Anders and my co-presenter is Paolo.
Hello.
Yeah, next slide. So first I'm gonna try to explain what LKFT is, and that is the Linux kernel functional testing. It's a project that is going to test all the stable kernels and Linux Next. We run a lot of functional tests like LTP and case self-test and lib huge pages, to name a few. Yeah, next. So from here and forward, I'm gonna tell you a story about a Swede and a guy from Italy that is trying to implement some benchmark tests into LKFT, and where we ran into problems, and we run into a lot of problems. It's not like functional tests, but they are fairly easy. It's pass or fail. And benchmark testing is a bit different. First, you need to know what kind of hardware you have, and you need to know the peripherals. For instance, IO benchmarking, you need to know what kind of IO device you have, and if you have multiple hardware, you need to have hopefully the same brand of, for instance, SSD disk. Otherwise, they can fluctuate in accuracy quite a lot, and you will see that we had some issues there further on. But then, what can we mean by regression? That is, if the average goes up or goes down, of course, but we need to figure out for different use cases if it's actually going up or going down. That is the
Anders, your audio is breaking up a little bit, so perhaps try to get a little closer to the mic and see if that helps. Thank you.
Okay, I'll try. Yep, next. So, first, back one. Doesn't matter, but first step, we had problems running on the hardware. It crashed a lot, and we ran the S suite that is maintained by Paolo to see the different schedulers, how they behave. For instance, BFQ, and everything was hanging for us in the first step. And next step that we ran, we got some results, but they were basically all over the place, and the data varied up to 20-25%, and we can't say much about those numbers if it varies that much. So we thought we could do better, and we managed to do a bit better. Next. We ran the suite for multiple times, and that helped. So instead of 20-25%, we got down to 12-15% of differences. and we couldn't draw that much of conclusions from that either. So we had to do even more, and we had to rework the timers because from time to time everything did hang, and we had some hanging issues as well that we sorted out. And with regards to different hardware and different devices of the same hardware, we had a lot of interesting issues there that was the same hardware but different peripherals, and that made it also be a lot of differences. So we had to narrow it down even more, and we managed to do that with doing a lot more additions. But we started off by doing too many, and then we finally narrowed it down to 3, 4, and that it looks fairly good then. Yeah, you can take the next one, or yeah. So now we are trying to implement email reporting tool for this as well. That's to find the thresholds. We need to look at data from 20 or 100 rows and produce some sort of email report out of that, and that's where we are right now. And I think Paulo is going to talk a bit more about that. Paulo?
Anders, you're still breaking up pretty bad. If you could maybe adjust your mic a little bit or try a couple things. Maybe turn off your video.
Yeah. Paulo, it's your turn.
Yep.
Okay.
Yeah. Okay, so I'll take it over from here. The second part of this presentation is, I want to show you some of the results that we have obtained using this health suite, and I want to use these results to motivate the thing that we would like to do next. That is adding an infrastructure for analyzing performance, and in particular for detecting regressions. But let's go one step at a time. So I want to show you these results with this S suite. I should have something ready here. So this is an example. Yeah. Here we go. So this is the test run for this build here. If we go to the bottom of this page, we can see the numbers that we obtained with this health suite benchmark. I will explain you the numbers along the way. So if we click here, we see these numbers here. What are they? So one of the main tests executed by this suite is to just measure how long it takes to start an application, to see the responsiveness, to measure the responsiveness of a system. In this case, the test application is just a GNOME terminal. We measure this while there is some background workload being served. In this particular first and simple example, the background workload is just nothing. So we have this 0 here, but I will tell you about other workloads in the background. And finally, the other parameter is who is controlling I/O. So this is the test. We start an application and measure how long it takes to start, of course with cold caches, because we want to measure something that has to do with I/O. Yeah, and we report that number. So from here we see that in about 1 second and 1.3 seconds, we have started this terminal. This happened if there was nothing in the background. We have some statistics, of course, on this number, as Anders told you. So average, maximum, minimum, and the standard deviation. Of course, as you can see, the average, maximum, and minimum are more or less the same when you have nothing in the background, because, of course, almost about the same will happen. Okay, so this is the result that we get where if we have as I/O scheduler, we have the BFQ I/O scheduler. So this I/O is being controlled by BFQ. But in the I/O stack of Linux, we have 4 I/O scheduler. So we also have Kyber, then we have this MQ deadline, and finally we have known, which is actually I mean, it's not an actual schedule, it's just do not control anything. If you have a look at the numbers, you can see that the time to start the application is essentially the same, whatever scheduler you have in charge. So with Kyber, we have about the same number that you have with BFQ, and the same applies to MQ deadline, and of course to no. So about the same value. Okay, so this is the base case. Basically, this is a case where a scheduler does nothing, because there is just some I/O coming and you just pass it through and dispatch it to the device. Things get interesting if you have something in the background. You have some additional workload being served. This is the interesting case. And for this case, for example, this benchmark tries several cases. One of the cases is if you have, for example, 10 files being read in parallel while you try to start the application. This is somehow an extreme case to see how good an I/O scheduler is, but it does give you an idea of how good you are in controlling I/O. And as you can see with BFQ, the time to start the application is about the same as it was when there was no I/O in the background. So it's 1.5, while here we had 1.3. So it's interesting to compare BFQ with the other I/O scheduler for the same case. But if we search for the results with the other I/O scheduler, so with Kyber or MQ deadline and so on, we don't find any number. Let's focus only on this workload in the background. Results are essentially the same with the other workloads. So if we check all the numbers here, we won't find results for this same workload. Why? To find out, we have to go back and look for the suite and see the results, and we will discover that the tests with the other scheduler have simply failed. Here is Kyber with the same workload, the same test. So trying to start the GNOME terminal. Why did it fail? Because the terminal didn't start at all. So we found out that if we have some I/O going on in parallel, we lose responsiveness completely on this board. It should be an X15 and with this kernel. Okay, so this is a rather strong result. Results are along the same line as the one that I have just showed you. So this was the first thing that I wanted to point out. So these results, so with this suite, we can now measure rather easily the responsiveness of a system, and we already have rather interesting results. We know that, for example, if we don't have this BFQ IO scheduler, then we lose completely control on this board if there is some other IO going on. We may lose completely IO because, of course, the situation is more complex than in a real scenario. So this was the first thing that I wanted to show you. The second thing is that I wanted to use this chasing of numbers to give you this impression of the fact that it is rather difficult to process these numbers. I think that you also had some difficulty in following me. So it wasn't that easy to find these numbers, compare them, and consider that, of course, you have been guided by me, and I already know these results. Let me just show you how easy it could be to check these numbers. Here they are. This is a very simple plot. We have the startup time for this known terminal. Of course, this is on a different device, so numbers are different. We have in purple the result with BFQ. So when we have these 10 readers, we make it in about 5 seconds. We have this reference red line here that tells us how long it would take if the device was idle. And so we can see that we have, with BFQ, we have about the same startup time as if the device was idle. But if we switch to the other schedulers, we have this axis that just tells us that the application doesn't start. The test waits for, if I remember well, 60 seconds or even 120 seconds, but the application doesn't start. Then the test stops and declares failure. So as you can see, it's extremely easy to understand these results if we look at this simple plot, while things are much more difficult if we have to follow this page and jump between failure numbers and back and forth and so on. So this is the motivation for what we would like to add to this framework. We would like to add something that, in contrast, makes it very easy to analyze performance and to, in particular, to spot regressions in performance. So hoping that I have convinced you a little bit, here is our proposal. So the problem is that in Linaro's framework, currently there is no support, no actual substantial support for performance analysis or for detecting regressions. It is not easy to do performance analysis as compared to functional analysis, because in performance analysis results are numbers and not just pass or fail. There is no fixed criterion to say, okay, these numbers are good, these numbers are bad. And actually the best solution, not easy, but the best solution is actually to learn from results. So given this not trivial situation, here is our proposal. We want to we would like to add 2 components. The first one is a component that should make it easy to extract and download data using some generic format. Anders proposed me TAP 13 or TAP 14, if I remember well. Maybe then Anders can tell you more on this, so that users can download this data and they can use the tool that they prefer, or can even use multiple tools and compare results. So this is the first contribution that we would like to give. The second one is to actually also give our tool. So propose a tool for analyzing this huge amount of data that we obtain from these continuous benchmarks on several boards, several systems, several kernel versions, and so on and so on. So, so the tool that we want to propose, we have several ideas on how to make it. One possibility is to make something based on statistical analysis, where this is sufficient. Should complexity be too high to be handled with just statistics, then maybe we could try AI. So we can evaluate this. regardless of whether we have statistical analysis or AI on the ground, beneath all of this, we would like to also add capabilities for easy visualization of data. As I hope I convinced you that that simple plot was much, much better than skipping among numbers. One extra feature that we may provide is some mechanism that allows a user, or does it on behalf of the user. So something that marks bad data, because that's another problem, a huge amount of noise in results. So something that somehow could help to mark bad data points or even automatically mark them. So this is basically what we want to propose. What else? To start doing this, we would like to use some benchmark as a concrete example for our first implementation. We were thinking of Hackbench because this seems to be a rather widely used benchmark. Then we may move, for example, to our S suite just because we know it very in depth. Maybe the cyclic test is another good option. So probably after we make this work on, I don't know, 3 or 4 different benchmarks, it's likely that we have something rather general, rather robust. And so probably it may work on maybe all the benchmarks available in Linaro's frameworks. Maybe after, I don't know, modifying a little bit the output of some of the benchmark. So the idea is to get to something that allows the user to actually do performance analysis and to be warned about nasty regressions. Okay, I think this is more or less all. So yeah, thank you.